can hear me well, because I'm not sure about it. Honestly, this is why I started the live stream 5 minutes earlier, so I wanted to make sure everything works perfectly fine. I hope you're still with me, because it's the third day in a row in which we're having a live stream. That's quite crazy, daily content, but I've told you already my exams are near, so I don't know how long it's gonna last. I mean, of course, after my exams. I'll just keep the screen, and yeah, you can see we are waiting for it. I'll also open my chat, so I will be able to respond to your comments while I'm live. Hope it works well. I have to check the audio. Give me a second. Yeah, okay, hope everything is perfectly fine. I'm also able to check the comments, so I think it's gonna be great. I don't know if you can hear the song. I don't know honestly, but yeah, we will just wait. That's what we have to do. 4 more minutes. Imagine after 4 minutes it's gonna stop. It's gonna be funny. But yep. I really like this background. It's great. Now we are just waiting. Also, let me check if the chat works fine. So okay. Yeah, it does. Okay, great. Hey, welcome to my channel, Leander's Life. I think you just subscribed. If I'm sure, I mean, I'm quite sure you subscribed today, right? Welcome on this channel. We are watching, I mean, actually we are waiting now for the webinar to start, as you can see. It's an official webinar from Unity. Welcome here. Thank you very much for the support again. And yeah, I'm very curious about it. I've never... Well, why do you took the message off? That's weird. Yep. Hold on, did you remove your comment or YouTube did it for me? Because that is very weird, actually. I watch almost all your live streams. Oh, I hope it's gonna be interesting. Hold on, why is your message like that? Wait a second. That is a bit weird. Give me a moment. I watched almost, yeah, I was the panda use guy. Ah, okay, so you are not that new on the channel, I guess. Wait, maybe it's because of, hold on. Show subscriber, show, you know what, I'm just gonna enable everything. So, I hope it's gonna work next time. Can you, wait a second. Can you now comment with an emoji again and see if they're gonna remove it? Because I'm curious, and also it's sad that it did this. I mean, I don't know why. I hope that was the reason when I fixed it, honestly. Maybe I can also drag them a bit more here. Maybe like this. Smiley face. Face blue smiling, face blue smiling, face blue smiling. It's so funny. We are gonna read the emojis, we're not gonna see them. Damn. So I trust you now. I think the live stream is gonna be interesting. Can't wait. We're gonna watch together this one. By the way, where are you from? If you don't mind me asking, if you want, you can. You don't have to reply. It's perfectly fine. I hope they also don't need my face cam or my voice or whatever, so I can be here with you in peace. Like this. Oh wow.
So, recording in progress. While we wait for some folks to tune in, we'll just go through some logistics. I'll introduce a bit of the session that we're going to go through today, and we will then also just make sure that you're aware of some of the things that we want to talk about. You can find out later on as well, so you won't be stuck in case you need to drop off early. So, where's everyone tuning in from? I'm based in Stockholm, so my name is Stephen Kent. I'm the product manager for the lighting product area here at Unity. And in Stockholm, it's a beautiful sunny evening. And I've got with me Maxime, David, and Jesper, and they are also from Unity. And I'll let them introduce themselves in just a second. Before we do that, though, just wanted to make sure that you're all aware that we're doing an audience poll. So this will really help us to provide you with even more awesome content in the future. So if you're able to help us fill in this poll, that will be super, super helpful to us, and then hopefully also helpful to you. All right, so this session, as I was saying, is about the lighting techniques that we applied in the URP 3D sample project. Maxime is your host. I'm just introducing everyone. So what he'll be going through is he'll be covering the latest lighting features that we've applied to the URP 3D Summer project. So there are some really key core concepts that we wanted to make sure that we include. So, how to use real-time baking versus, real-time lighting versus baked lighting, what kind of editor tools you can leverage, like, light maps, light probes, reflection probes, ambient probes, and a lot of information about environment lighting and post-processing. We're going to make sure that you're aware of how you can visualize some of that lighting data so you can then debug any kind of issues that you might have. And there's a ton of other lighting tips and tricks that we'll be covering. And we'll also be teasing something that we built for Unity 6. So even though the session is, the bulk of the session is focused on the lighting features that are available to you right now in the 22 LTS release, we'll also at the end tease with some really cool stuff that we've been building for Unity 6. So sit tight. Okay, that's me. As I said, I'm Steve. Really great to be here. And I'll hand it over to Jesper to introduce himself.
Hi, I'm Jesper. I'm a lighting engineer from the Copenhagen office, and I work on GI and lighting. So I'll be answering questions in the Q&A session. Over to David.
And in much the same way, I'm David. I'm a product designer working in the area of lighting and graphics. Looking forward to answering your questions.
And I'm Maxime, a senior technical artist working for lighting in Unity, and I'll be the speaker today.
Great, yeah, thanks all. Okay, we're going to get started in just 1 minute. So this presentation may likely run a bit longer than 45 minutes because we have a ton of content to cover. But don't worry, we'll of course hope you stick around for the full hour, but for the full 45 minutes, and there'll be Q&A after that as well. But if you can't, you'll receive this recording in your inbox in just a couple of days after the session is ended. Great. Maxime, over to you.
Yes. All right. So can you all see my screen?
Yep, looks good.
Great. Okay. So today we'll explore the Oasis and Garden scene from the URP sample using the 2012 TS, and we'll focus on lighting. So we did a previous webinar about the URP sample, so you can take a look afterwards if you need other informations. So first, we'll cover some lighting basics to remember some concepts like diffuse, specular, direct, indirect lighting, real-time and backlighting. Then we'll discover some tools like light probes, light maps, reflection probes, ambient probes, and multiple debug views. So this first part will mostly be targeting beginner users and hopefully give a first overview of many tools that we have available in Unity. And then we'll cover more advanced topics like more details about shadows, light setup, light mapping issues, volume, post-processing, so a lot of stuff. And then we'll take a look at adaptive probe volume in Unity 6. So we'll discover the feature and I'll show you some recent improvements that we've been working on, including a new anti-leak solution. All right, so I pre-recorded videos mostly because I'll be baking lighting multiple times, so I can skip the baking times to go faster. Okay, so let's start with the basics. Like, let's see what we can learn about lighting using the debug views. So we can take a look at the Oasis with this beautiful sunset lighting and see what we can learn from this scene. So usually the first thing I like to do is take a look at the rendering debugger, be your best friend when working with lighting. So you can see one of the debug view, for example, the lighting debug view, and it's super useful to inspect the rendering of your lights. I'm using this all the time. And something great is that you can also isolate some of the components. For example, you can look at the direct lighting from the sun. So shadows are completely black because we are not seeing the bounce lighting. So this is the direct lighting because the light is coming directly from the light source, the sun. If you want to find a light like the sun, you can also take a look at the light explorer. That's super useful if you want to inspect a scene. And as you can see, if I move the sun, everything is reacting real time. We are seeing real-time direct lighting. Then we can also take a look at the global illumination debug view. And everything is much smooth, much softer. The light is bouncing around. For example, you can see the light from the sky softly entering the tent. You can see the light from the sun bouncing off the sand and illuminating the cliffs. And if you want to do realistic lighting, you'll need both direct and indirect lighting. And this time, let's select the sun and move it. And you can see that if we move the sun, everything is static. That's because indirect lighting can be really expensive. And so we pre-compute it, it's baked. So baked lighting is very important for performance. It means that for a static scene, we can get great visuals that run well on every platforms. So then let's take if I move the view, we can say that the lighting stays the same. That's because some of the incoming lighting is scattered in every direction when hitting the surface. It's called diffuse lighting, and it does not depend on the camera position. So here we are looking at direct and indirect diffuse lighting. But we can also take a look at the reflection debug view to look at the specular components. So this time, everything depends on the camera angle. So that's mostly visible for metallic objects, for example, but it's actually true for every surface that you can see. So same as before, you can see direct specular, directly coming from the light. And you can also see indirect specular, so the reflections of the rest on the environment. So we've seen direct and indirect lighting for diffuse and specular, and each of these concepts has a specific tool in Unity. So for example, if you go back to the Light Explorer, you can see that we have some reflection probes, we have some light probes. So that's tool that we are going to discover very soon. So now let's see how we can set up this scene from scratch. So I'd like to take a look at the default lighting to understand what's happening when you start lighting your scene. So I cleared the backlighting, deleted all the lights, restored the lighting parameters. So this is the lighting you should see by default. So as you can see, it's not great. It's quite different from what we had before. So what do we see? Where does it come from? So I can create a sphere to get a better look at it.
I'm so sad.
And that's it. Let's create a material.
I can't do anything about it.
So basically, we are looking at the indirect diffuse lighting, and Unity creates something that we call ambient probe, and it represents the lighting coming from the sky. So to know more about this, we can open the lighting window and go in the environment tab. You can find the setting for the sky. So for this, you can choose if you want the skybox or custom colors, for example, and you can see that the ambient probe is affected and lighting our objects. So for this scene, I'd like to use the skybox. Then let's modify the material to look at the indirect specular lighting. So basically the reflection from the sky. And you can do the same. Does it come from the skybox or from a custom color? And as you see, the ambient probe and the ambient sky are very simple. Static mesh are not contributing to lighting. Light is not bouncing around. So every object is lit as if it was floating alone in the sky. So it's usually a fallback that you use when nothing else is available. Okay, so when setting up a scene, the first thing that I like to do is to set up the sky. So I'm using a cube map texture. It was generated using the PBR sky from HDRP and baked into a texture. So you can see it here. And yeah, basically we are starting to build the look of our scene. So at least we have the right sky, a slightly better ambient lighting. And now we can see, let's see how we can use more powerful tools. So what do we need in order to bake lighting?
Hey, Maxime, can I just jump in? It seems the resolution of the video is really not that great.
Oh.
Is there you could do to help increase to, I don't know, say 1080 for the next step?
I don't know, like the video for me is 4K, but maybe it's the shared video that is not great. Let me share again. So let me try. Madison, do you know if there is any option in Zoom for this? So you can't see the option I'm showing basically.
It may perhaps go to, when you share video, go to there should be another tab that says advanced video settings.
Yeah, I can optimize for video clip, and maybe I'll turn my webcam off so it's slightly better. Let me try again. How is it?
I find that I personally am finding that clear. Okay, we're getting good feedback. Thank you all so much.
Okay.
Okay.
Thank you.
Wow.
Thanks for jumping in.
Great to have Maxime, and thanks
Thank you
for helping. Okay.
Yep. So let's look at the setup that we need to do to bake lighting. So we need to take a look at the mesh renderer. So for this, the contributor receivers debug view is great. Basically, here you can see that everything is yellow, so nothing is contributing to lighting. So let's select the mesh renderer, and then there is the static option in the right corner, this one. And when you check it, you can see that it's contributing to global illumination and using light maps. So basically, I want to set as many meshes as possible to static so that light can correctly bounce off these objects. So that's what I did for this scene. You can see that some of them are using light maps and the others are using light probes. So we'll speak about that in a moment, but the important part is that many meshes are contributing to the lighting, to the global illumination, so we are almost ready to bake. So we'll start by baking the indirect diffuse into light maps. And for this, the question that we need to answer is where do we store the bake results? So light map are textures, so we need to check the UVs for our meshes. So that's a huge constraint when working with light maps. And so you can check it on the mesh itself. You can see that here we have light maps UVs with no overlap, so that's great. And that's the case for all of the mesh in our scene, so we can basically start the bake, but yeah, that's what you have to check before doing anything with bake lighting and light maps. And it's already much better, so we can have a closer look. So the light from the sky is bouncing off objects, entering the tent, and we can look at the previous result for comparison. Yep, so the ambient probe was illuminating everything uniformly, and now we have nice occluded areas in light maps. So we can inspect the statistics. We have 2 light maps textures for a total of 20 megabytes. And we can see the light maps in the Bake Light Map tab. And if you select an object, you can see where the UVs are packed in the texture. So that's quite useful if you want to inspect the light map. So we also have the Bake Light Map debug view. There you can see the resolution and all the texels. So it's quite clear that lighting is baked into texture when looking at this view. So yeah, currently we bake the lighting from the sky into light maps. Light is bouncing around, but we are still missing some key components.
Hey, Maxime, just jumping in one more time.
Yep.
But can you try resing your video by going to that to the settings bottom right?
Oh yeah, sorry. This. Okay. Yeah. I thought it was done, but apparently it goes back to auto. Okay, I'll do that every time.
Thanks.
Yep. Okay.
Damn. This is so fun.
So we are missing a sun, the key light for our scene. And with it, we'll need both direct and indirect lighting. So we can add a directional light and tune the parameters, like the color and the intensity. Then we can enable the shadows. And if you want soft shadows...
Maxime, just again, can you try one more time to click that cogwheel down there just to make sure that the resolution is how we want it?
Yeah. Is it fine? So I'm so sorry for the video quality. I don't know. Looks fine on my side, but I guess that's the Zoom sharing part that is not great. Okay, I'll just continue, and I hope it will work. I'll try to explain every option I'm clicking on so you can understand what I'm doing. Oh, sorry. So directional light, and basically you need to go into the URP settings if you want the soft shadows, URP asset settings. And let's go there, and you have the soft shadow option. Okay. Then you can rotate your light to create the nice sunset that we want. Okay. And then we have the lighting mode. Basically, with real-time, there is no baking, so only the real-time direct lighting. With mixed, we have some baked data, for example, the indirect lighting. And with bake, we bake both the direct and indirect lighting. So for static lights, mixed is a very good choice because direct lighting will be computed at real time. So it means we can still have the animated shadows for the vegetation, for example. And the indirect lighting will be pre-computed, so we can have that nice bounce lighting. So let's take a look at the scene and rebake. First, we can enable the global illumination debug view. And when we bake, we should be able to see the lighting from the sun. Okay, so you can see some yellow light that is bouncing around. So that's the sun contribution to global illumination. It's quite subtle, but that's the kind of detail that make the difference for the final image. So the sun is there. We've updated the light maps. Let's see what we can do to increase the quality of the scene. So even if we simulate realistic lighting behavior with global illumination and bounce lighting, we still have a lot of artistic controls. So for example, in the scene, I think everything looks too orange, like it's quite monochromatic. I don't like it. And currently it's because the lighting is coming from the sky and the skybox is quite orange near the horizon. So I can go into the lighting settings and instead of the skybox, I can choose a custom color. I'd like to add more blue, so let's try with this. So you can see it's only affecting the objects that don't have light maps. For light maps to be updated, we need to rebake. So let's use a gradient of blue. And let's rebake. Okay, so it seems quite good, less monochromatic, and the blue in the shadows is adding some contrast with the color of the sand. So I like it. So it's quite useful to play with those environment settings for backlighting. You can basically do whatever you want, depending on the mood you want to give to your scene. So now we can also focus on the indirect lighting from the sun that we baked just before. So if you like the bounce lighting, you can boost it with the indirect multiplier, for example. So let's go into the light, indirect multiplier, maybe 1.5, let's try. And that's slightly better, maybe 2. It might be a bit too much, but it depends on what you want, yeah. So you can see you just increase the bounce lighting. So with these options, we are getting away from realism, but that's a choice, and it's useful to know that you can do it, especially if you want to give a specific mood to your scene. Okay, so our scene is looking slightly better. So now we can take a look at the basics light mapper settings. So everything is in the lighting window. In the scene tab, you can control the quality at the expense of the baking time. So you can use presets and store that into assets. For example, I'm using the Oasis lighting settings. And there you can tune a lot of stuff. So first, I'd like to make sure that I'm using the GPU light mapper. So the results will be the same, but it should be much faster if you use that and if you have a standalone GPU. And after that, you can control the sample count. So it drives the quality, but is directly linked to baking time. Basically, that's the number of rays that are fired to compute global illumination. And if you try with something that is very low, for example, 4 sample counts, you can see that you have a lot of noise in the baked results. So we need to find the balance between quality and computation times. So in this video, I'm speeding up the baking times, but here with this result, it takes around a minute on my GPU to bake. So you can also modify the light map resolution. So let's look at the bake light map debug view. And the resolution will affect memory, quality, and baking time. So with a very low number, for example, let's try 1. And currently I'm using 40 megabytes for the light maps. And if I bake again, now it's using 1 megabyte. So the result is not great. You still need to find the balance between quality and the size of the resolution. So we'll pick back again with a better resolution, but basically it's good to know that you can manage the light map resolution in here. And yep, so you'll also find some other parameters like the ambient occlusion, for example, if you want to bake it, some denoiser options, and some other artistic controls like the albedo boost. So we won't take a look at everything, but don't hesitate to play around with those if needed. So we baked indirect lighting into light maps for some objects. So let's see what we can do for the others. In the scene, many objects inside the tent, for example, are not using light maps. The pillows, for example, are still sampling the ambient probe. They are missing in the light map debug view. So let's see, they are quite blue, so sampling the ambient probe. And that's because light map are not a perfect solution. Some assets might simply not have UVs, or with too many objects, light map might use too much texture memory. But most importantly, it does not work with dynamic objects. So what about characters? What if you want to move the pillows? So these objects need a specific solution for baking, something that would work for any kind of object, regardless its geometry or its position in space. So we are going to use light probes. You can create a light probe group, and you can see multiple yellow spheres. So these are probes. And the light probe stores the incoming lighting at a given point in space. Then at runtime, dynamic objects can evaluate a network of probes to get an approximation of the pre-computed lighting. So light maps are based on 2D textures linked to a specific object. Probes are in 3D space and form a volume. So we can move them, create more probes, and the more precision you need for your indirect lighting, the more probes you can place. But this process can be quite time-consuming. So we'll speak later about other solutions for this. Currently, I'll skip the probe placing part, and we should now have probes in the tent and outside. So yeah, a bit more probe near the walls to avoid the leaking. And outside, we don't need that many probes. It should do the job. So now that we place the probe, we can rebake and look at the pillows to see the difference. And that's much better. The tiny and movable objects inside the tent now have some nice indirect diffuse, and you can move them and see the transition from light to dark when entering the tent. So it works with new objects, of course. Any object can sample the probes. But you have to know that with these probes, the sampling is per object, so it's not great with big objects. As you can see, it can either sample the inside or the outside of the tent, but not both at the same time. It's only evaluated once per object, so it does not work with big objects like that. But anyway, indirect lighting is baked for both static and dynamic objects. So what else can we do to improve the rendering of the scene? So we are missing indirect lighting, indirect specular lighting. If we look at the object, for example, the metallic object inside the tent, you can see that it's still sampling the ambient sky. So it's not great. So yeah, quite visible for the metallic object inside the tent, but actually true for everything in the scene. Overall, the sky reflection makes everything look too bright. So what we can do is we can create a reflection probe. It will capture a cube map texture, and it will be evaluated at runtime to get an approximation of the environment for specular reflections. So let's bake it. And let's see the difference it makes. Yeah, as you can see, it's quite visible. So for reflection probe, you can play with the influence volume. So everything that is inside will sample the reflection probe and everything else will fall back on the ambient probe. So we can roughly place it around the tent like this. And something to remember is that we set our mesh renderer static. And if you look closely in the static drop-down list, you can see that we have the reflection probe static option. And don't forget to enable it, because if you don't, the object won't be rendered into the reflection probes, and you might see a lot of leaking. Like here, for example, the sky is baked into the reflection probe. So be careful with your mesh renderer settings. We can place a few other reflection probes. It really depends on the scene and the quality that you want. For this scene, a couple of them for the exterior will be just fine. So one above the water, for example. Yep. You can see that it's also making a tiny difference on the vegetation. Okay. And then another one near the cliffs. And yeah, we can look at the debug view to see exactly what it's doing. So this is the reflection using the ambient sky, and this is when you use the reflection probe. So much better and less leaking. Then, if you look closely, you can see that some of the reflection probe are overlapping. There is the small one and the big one. And Unity is sorting reflection probe by size, and by default, smaller reflection probe take priority. But there is also an importance parameter if you want to deal with it manually, like this. But in our case, we don't want to do this. Okay, so we've seen multiple lighting tools, light maps, light probe, reflection probe, and our scene is looking great already. So we can jump on slightly more technical subjects. So it's time to see if we can improve the direct shadows. So let's focus on the directional light. And yep, so some of the settings are in the URP asset. So let's see what we can tune. So first, you can modify the resolution of the shadow map. But that's not the only parameter. Like the max distance has a huge impact. With a short distance, we get a better quality because the shadow is covering a smaller surface, but it's hard to get good quality and large distance coverage. That's why we have a cascade parameter, and we can use multiple shadow maps, some for close range, some for long range, and each one will be covering a different surface. So let's see how we can do this. So 3 for the cascade count, and we have 3 shadow maps. And the cascade shadow map debug view is great to see what's happening. So as you can see, we can adjust the distance for each of the shadow map. And the last one is covering a larger surface as we don't need as much detail in the background. If you take a look at the multiple quality assets that we have in the project, you can see that for PC, we use up to 4 cascades, but for mobile, it's only 1 shadow map. So you should know that it's affecting performance, so it really depends on your platforms. But then the question is, what happens after the max distance? As you can see, currently we are fading to no shadow at all, so that's not great. Let's see if we can do something about this. Like, let's see if we can bake the direct shadows. So in the lighting window, in the lighting mode, you can choose the shadow mask. It will bake the indirect lighting like we did, but it will also bake an additional mask for the shadows of the mixed light. So let's look at it. There it is. So it's low resolution, it's static, but it definitely does the job for the background. So we can use that as a fallback after the max distance of the real-time shadows. Let's try to zoom out. Yeah, you can see that we have shadows even from very far away now. And in the project settings, you can decide if you want this shadow mask to completely replace your real-time shadows, or if you just want this as a fallback. So if you choose shadow mask, everything will be static, and you are not using any real-time shadows for the sun. So in our scene, let's choose the distant shadow mask. This way we can have animated shadows in the foreground and bake shadow in the background. Okay, so I'd also like to take a look at the garden scene and the shadow mask. So we have multiple lights in here. And as you can see, we can bake multiple lights into the shadow mask. So in this scene, we have like the red one, the blue one, and the green one in the debug view. So 3 lights, 3 overlapping lights. But what happens if we add more lights? So I'm adding a red mixed point light and a blue mixed point light. And let's see what happens. So if we look at the debug view, we can see that we have another light, so 4 overlapping lights, but not 5. That's because 4 is the hard limit for the number of overlapping light that you can use with shadow mask data. So the red light is a mixed light, but the blue light has automatically been converted to baked. So this is something you have to be careful with working when you work with shadow mask. You should check the range of your light to avoid having more than 4 overlapping lights. So since we are in the garden scene, let's see how we can set up a slightly more complex lighting. Like in the tea room, for example, we have multiple type of lights, not only a directional light, so it can be difficult to choose the right tool. And let's see how we can do this from the beginning. So the main light source is at the ceiling, and one idea is that you could use emissive to bake lighting. So this is completely possible in the material. You can use the emissive if you set baked in the global illumination parameter. You can increase the intensity of the emissive, and let's bake. Okay, so it's working, but the result is not great. The lighting is quite uniform, and it's not really the mood that I want. And this setup is not practical. Like the shape of the mesh is influencing the lighting. The emissive is also affecting the bloom. So I guess we need more control. So let's use a lower emissive and see what we can do. So can we try with a mixed point light? We need light in every direction, so it could be a good solution. So let's place a point light. Can tune the parameter. So the color. All right, the intensity. We want shadows. A mixed light to bake the indirect lighting. Oh, I don't want the indirect multiplier to be 5. Okay, let's bake. And it's looking better. I think the ceiling is a bit overlit, so it would be great to have more control on the light direction, for example. It would be great to be able to highlight the table at the center of the room. So let's see if we can do something else. And also, point light shadows can be expensive since we need shadows in every direction. So let's see if we can do something else. So I'll reduce the intensity of the point light and switch it to baked for performance reasons. And let's bake again. So yeah, it gives us a dimly lit atmosphere, and that's something we can build we can build on top of this. So I'd like to add a mixed spotlight to highlight the main subject of the room, the table. So let's see if I can do this. So same, I can place it and tune the color and the intensity. And for the spotlight, the real-time shadow will not be as expensive as the point light because we need shadows just for the bottom direction. So it's better for performance. So let's use a mixed spotlight and bake again. And that's nice that this setup is great to balance the amount of light you want for the room or for the table. So that's quite useful to use multiple lights for stuff like this. So you can really focus the lighting on something that you want. So let's see what we can do for the rest of the room. So we can try area lights. So this type of light is only baked for URP, as you can see, but that's not a problem. We have light maps and light probes and reflection probes, so we can bake it. Let's try with something blue to have a bit of contrast with the rest of the room. And let's bake again. Perfect. So as you can see, it can be quite useful to try multiple lights. You don't have to conform to the existing lamp mesh of your scene, and you can combine multiple lights for the same, to do a specific effect if you want. And that's super useful for this kind of scenes. So still in the garden scene, we can take a look at the exterior and see how we use the rendering layers. So for this mesh, we are using two lights, a small one to illuminate the mesh itself, and another one for the rest of the world. Like this one for the rest of the world. So notice how we use rendering layers, and the mesh itself is on another rendering layer. So it means it won't be illuminated by the lamp. So if we modify this, you can see I don't really like the pattern that it does. It's a bit too bright and the high frequency shadow is a bit disturbing. So that's why rendering layers are great if you want to restrict the light to specific objects. So you can create a new rendering layer in the URP global settings, like this. And yeah, it can be useful in many cases, like to solve artifacts like leaking or for custom effects, since we are not restricted to realism. Okay, so now let's go back inside and look at the light cookies. It's a great tool to adjust the look of your lights. So if you inspect this light, you can see that we have a nice looking soft shadow that is reacting in real time, but the shadow option is turned off. So what's happening? So it's actually a cookie. It's a texture that we use to dim down the light influence, and you can see it here. So light cookies are an amazing tool for both artistic and technical reasons. So for example, you can simulate any light effect with pre-computed textures like caustics, fake shadows, so anything that you want. And that's quite cheap to use. It's not a real shadow, so it works for a lot of platforms for mobile. So keep in mind that since the shadow option is not on, it does not cast any shadow on other objects. So it's only faking its own self shadow So that's why we kept the range quite low for these lights. But many lights in the garden are using cookies. So yeah, total control over the look of your light. And it's really performance friendly. So it was super useful to simulate many shadows on mobile platforms. So let's go back in the Oasis scene and take a look at lens flares. So it's a photorealistic effect happening when the light is bouncing around the lens of the camera, creating interesting artifacts. So I can increase the intensity of the effect so you can see it. So that's something we are really used to seeing on films. So it's also a good way to give a specific look, like a bright, dazzling sun in this case. And with Unity lens flare component, you can create lens flare from scratch. So you can add and control multiple elements like circle, polygons, images. And yeah, it's really easy to create a new component, for example, a polygon, and you can offset its position, the scale. So you can modify the color if you want. So you can do a lot of stuff to do the exact lens flare that you want. And yeah, as you can see, you can also use textures. And with the texture that we have in the project, you can do some quite realistic effects. And that's quite easy to do. So don't hesitate to reuse those textures if you want. And there is also the occlusion parameter that you need to enable if you want some occlusion. And you can also tune other parameters like the sample count for the occlusion to set up the way it should fade out when occluded. So custom lens flare are great. And with a few polygons and images, it's relatively easy to get convincing results. And it adds a lot to the final image. So speaking about the final image, there are many effects that you can add on top of your image to make it look better. So let's take a look at this. So if you use the rendering debugger, you can disable post-processing, and you can see that it makes a big difference. So let's see where those effects come from. So at a project scale, you can add some effects. And you can see in the renderer, you have a global volume feature. And let's look at this. So we have a few effects. Can you hear me? My headset just disconnected. I guess I'm back. Okay, so tone mapping. So the tone mapping is super important. It makes sure that the values of your image fit within the range of your monitor. So for example, the skybox is super bright near the sun and it has values above 1. So we need to remap all of these values so it looks good even on an 8-bit monitor. The bloom effect is great to fake intense luminosity. So it makes the light bleed around object to simulate a dazzling effect. And yep, you can also find the vignette effect in here. So basically, a lot of effects that are there for all the scenes in the project. Then we can also look at another screen space effect. And yep, in the renderer, you have the screen space ambient occlusion. And that's great if you want to add high frequency detail in the indirect lighting, especially with low frequency baked lighting. So super useful, yeah, for the contact indirect shadows, for example. So now that we've seen the effects that are added on a project scale, let's see what we can do for this scene. So we can add a volume and an override. And we can override the default values, for example, the post exposure, and you can adjust the luminosity of your scene. With the shadow, midtone, highlight, you can work on specific ranges of your image. For example, you can offset the dark values toward the specific color, like purple.
Give me a second.
We have also the white balance. It's super cool to shift the whole image towards a warmer or colder look. It's also great if you want a specific object in your scene to look white. So yeah, there are a lot of effects that you can add for your scene. And you can, let's see how you can add effects to a specific location. So for example, I can create a local box volume and place it around the tent to add an effect that we would only see when the camera is inside the tent. Yeah. So let's modify the collider of the volume. Let's place it roughly around the tent. And then if you add an override, for example, the exposure, you don't see anything until the camera is entering the volume. So that's great if you want to simulate the eye adapting to the luminosity when entering the tent, for example. And you can also adjust the blend distance on the volume for this. All right, so the scene is starting to look very good with all the effect that we added. Let's see what else we can do. So maybe we can create some custom post-processing. So that's what we did in this sample for the fog. If we look at the lighting window, you can see that the fog is disabled. And we did create a custom fog. Let's see. Yep, you can see it. And so you can tune it in the volume. So for example, there is this sun scattering intensity. It's quite localized in the direction of the sun. So it's looking good. And we have the height range for something based on the altitude. So this fog is a bit more complex than the default one. That's why we created it. And you can see that it's using a custom path. And for this, you can use material. So if you want to create a material for a custom path, you can create a shader graph, full screen shader graph. So let's look at this material to see what we are doing. So first, let's look at the blending mode. You can see that it's using alpha. So the effect will be on top of your image. And then something great with URP is that you can get information about the light in your scene in the shader graph. For example, the sun color or direction. So you can base your effect on this. And if we move the light, for example, you can see that the fog is reacting. And if you modify the color, like a blue sun, you will get a blue fog. Then you can also take a look at this if you want. We won't look at everything, but there is the height parameter and the distant fog. So can take a look afterwards if you want to see how everything works. So we created the material, but then how can we expose this in the volume system? So we did a script for this. Let's look at it. And basically, we are just creating a volume component and exposing a few variables. So you can create, we are just creating the parameter that we want to see. And then in the full screen path, let's look at the script. We are just getting those parameters from the volume, assigning this to the material, and that's it. And then we execute the rest of the code for the full screen path. So yeah, take a look at this example if you want to create your own custom effects. It can be incredibly useful if you want your image to look a very specific way. So, yep. So the scene is looking great. So now we can focus on some of the technical problems you can face when dealing with light mapping. So, for example, these rocks, there are a lot of intersecting geometries. And if we look at the debug view, you can see many artifacts, some black outlines around the intersections, some black pebbles. And remember that the ambient occlusion is disabled, so that's not a wanted behavior. That's just an artifact, and we need to fix it. So if we look at the resolution, we can start seeing the reason. Many text cells are partially covered with the geometry, and they might hit many back faces during baking. That's why they are turning black. So the first thing that we can do is increase the scale in the light maps. Let's see what it does. But that's better, but that's not possible for every object. So we need to find another solution. So we have the light map parameters and the backface tolerance. So let's look at the text cell validity, and you can see that some of the text cells are red and invalidated. So let's modify this value and see what happens when we bake. So it's looking better, and if we look at the debug view, we can see that we have a lot more text cells that are invalidated. It means that Unity will automatically apply a dilation filter, so basically replace their value with adjacent valid text cells. So basically we use valid text cell to fix the invalid ones, so that's super useful. We can fix some of the black outlines this way. Let's look back, yeah, but we cannot fix everything with this. For example, for this pebble, you can see that we have invalidated text cells, but no valid text cell to fix it. So it won't do anything. So let's see if we can do something else. So same in the light map parameter, we have another option, the push off. And basically during baking, rays are fired from the text cell position, but we can offset the ray start position along the normal. So it's a very good way to avoid intersecting geometries. So for example, if we increase this, the ray will start slightly above geometry. So we will not hit back faces. So we can try this, like maybe something like 15 centimeters for this. And let's bake again. Yep, so something happened. It's not fixing everything. But the cool thing is that we can apply this on different meshes, so we can apply different settings. So for example, for this mesh, I can easily create some custom parameters. So the pebbles on the left, and apply like 30 centimeter push-off, for example, let's rebake, and it's fixing this only for this mesh. This way you don't have to apply the offset for the whole scene. So it requires some experimentation before finding the good values, but that's super useful to fix light mapping artifacts. And I'd like to take a look at the garden, because we use this also in the garden. If you look at the grass, you can see that it has some custom light map parameters. And we actually did a 8 centimeter push-off. So to understand why, let's look at the ground. And you can see that we are actually using a parallax effect. So the mesh of the ground is much higher than it seems. So if we don't use the push-off and bake, we will see the shadow of this mesh on the grass. So that's why those custom light map settings are really necessary. Here you can see we see the shadow of the ground, so that's not great. Okay, so when dealing with light mapping, we can see a bunch of artifacts, and let's take a look at the other ones. So for example, if you look at the UV overlap, you can see that you have some issue with those rocks. So let's look at the light map. And you can see, let's look at the debug view, the UV overlap. So you can see that some of the text cells are red. So it means that they are shared between multiple UV islands. So that's not good. And basically what we need to do is to increase the light map resolution for this mesh if we want to fix the issue. Can do it here. And I also added some other objects in the scene, and that's because I want to focus on the leaking that we can have. So for example, we have leaking from the inside, and here we can see the bright light from the outside. And I want to understand why, what's happening. So let's look at the debug view. So first, we can see that some of the texels are shared between the both faces, though that's not good. If we look at the UVs, we can see that we have actually no seam between those two opposite faces. And that's something you have to be careful with when baking light maps, because those two areas with different luminosity will get really close in the light map if you are not careful. And light map use MIP maps, so it means that at a distance we'll use lower resolution texture. So let's see what happens. If you use lower resolution texture, you can see that the leaking is increasing, so that's not good at all. So you should be really careful with your UVs when you are dealing with light maps. So something great is that Unity can generate light maps UVs for you. So you can do this here, and then you have some options to add some seams based on the face angle, for example. So let's apply this and rebake. So it's creating a channel 1, and you can see that you have the spacing that you need between your islands, and that should be good if we bake again. Yep, so no more leaking for this. So something else that we can look at. So yeah, on the light maps, you can see you have the right spacing between all of your islands. Something else that we can look at is the light map padding. So basically what we did before is add spacing between the UV islands of the same mesh, but we can also add spacing between different meshes with the light map padding. So let's try with something like 8 instead of 2. Yep. And yeah, you can see that now you have 8 texels between the different meshes. So that's the same problem that you can have with MIP maps and bleeding and leaking. So yeah, you have to be super careful with the packing of your UVs. And now let's take a look at the seams we can have. So you can see we have some seams on the sphere. So to understand why we have seams, let's disable the denoising so we can take a look at raw light maps. So you can see we have a lot of noise. So the denoiser is doing a great job to hide this, and it's working in light map space, so in a 2D textures. So when we have UV seams, it doesn't work that well. That's because UV islands are not close to each other, so they are denoised. They are not denoised the same way, and that's why you can see the seams. But you can see that on the mesh renderer there is a parameter called stitch seam. So let's try it for this one, and this sphere is split in 2 meshes. Let's try what it does. Okay, so it's much better on this one, but you can see that it's only working for at a mesh scale for a single mesh. It's not working between different meshes. So that's something you have to know. If you are building a world with many modular meshes and you have a lot of seams, you cannot rely on denoising for this. So you should just increase the sample count to have less noise, and then you can hide the seam like this. So yeah, it will increase the baking time, but that's the only thing you can do. And finally, I'd like to speak about light maps and LODs because we implemented something custom for the URP sample. So if you select a mesh renderer, you'll see that you have multiple LOD levels, and only the LOD 0 is using light maps. The other one are using light probes. And you can see that if you use the contributor receiver debug view. As you can see, we are switching from light map to light probes when we move the camera. And so is it is it visible in the view? Because I would expect some kind of popping when we switch between light maps and light probe, but we cannot see it. And that's because we did a script to basically share the light maps between the different LOD levels. So let's look. So what do we do? Basically, we take the light map from the level 0 and we assign it to other levels. And yeah, this is super helpful. So you don't have to bake light maps for every level. So you can save a lot of space. So let's take a look at the scene if we remove this. So we need to reload the scene. Yeah, so now you can see the popping when we switch from light maps to light probe. So that's not working. Basically, there is too much difference between the light map and light probe lighting. So that's not great. So basically, we want to use light map for every LOD levels, but let's see what it does. So currently, for the light map that we have, it's like 130 megabytes. If we bake light map for all the LOD levels, let's see what it does. So instead of 130 megabytes, it will be 212 megabytes, so a lot more. So for basically nothing, because as you can see, if your LOD levels use the same UVs, it can be a great solution to share the light maps and save some space. So don't hesitate to take a look at this script and reuse it in your project if you need this kind of stuff. So I won't cover all the light mappies issues today, but you can take a look at this Unity blog post. So that's amazing resource if you want to learn more about light mapping, especially the light mapping troubleshooting guide. So look at this. And that's it for the light maps and light probe. Let's go and let's speak about adaptive probe volume. So that's a Unity 6 feature. So it's a bit of a teasing. So I'll be quite quick to present this. But basically, that's the new light probe system. And we'll see how it can be useful to replace light probe groups or even light maps. And for those of you who already know the features, you know that light leaking can be quite problematic. That's why I'd like to show the recent improvements we've been doing based on your feedback. So let's take a look at the Oasis again and at the setup. So if you remember, we are using light maps and light probes. And it was slowly placed by hand, so that's not great. So let's try with adaptive probe volumes. So in the URP asset, you can switch from light probe group to APV, adaptive probe volume. And then in the lighting window, the adaptive probe volume tab, you can set the min and max distance between probe. So here it's between 1 meter and 27 meters. Then it's a volume-based system, so you can just place volume in the scene. You won't have to place the probe by hand. In the rendering debugger, you can enable the live update, so you can see the bricks of probes in real time to see where you will have some probes. And then you can place your volume. For this one, we don't need the full resolution. We don't need all the subdivision levels. So let's just use like between 9 meters and 27 meters between probes. It will be for the whole scene. So you can see the bricks of probes that are generated. And then we need more precision for the tent. So let's create another volume. And for this one, we want to use all the subdivision levels up to 1 meter between probes. And let's place it around the tent. Okay, so we can bake probe volume. And then we should be able to see probes using the rendering debugger. So as expected, we have a lot of probe for the tent and a bit less for the rest of the scene, and everything was generated automatically. So these are light probes. So it should work with dynamic object. Let's try. I can add a cube. And APV is providing per pixel lighting. So you can see all the detail in the cube, all the different shades on the cube. It's dark inside the tent, and you can even see the bounce lighting of the sun outside. If we compare with the old system, so remember light probe groups are sampled per object, so the cube lighting is uniform, so that's not great. That's why APV gets much better quality with the per pixel sampling. So now the question is, if we get nice per pixel lighting with APV, can we also use it to replace light maps? So this way, if we don't use light maps, we would not have to deal with UVs, and it would be a unified solution for static and dynamic objects. So we need to modify the settings of the mesh renderers. Currently, some of them are using light maps. So let's do this. Let's select all the mesh renderers and set light probes. Then we can rebake and take a look at the result. Hey, so it seems to work. So the first thing that we can notice is that directionality is much better with APV than with light maps. For example, the normal maps are much more contributing to indirect lighting. But we need to see if we have issues. Like, let's take a look inside the tent. Yep, let's take a look. And yeah, we have a lot of light leaking. So that's because the walls are really thin, so we can see the bright light from the outside in the interior, and that should not be the case. So we can use the probe sampling debug view to see what's happening. And we can select a pixel and see the probes it is sampling, and the result is interpolated between the bright probe outside and the dark probes inside. So we should not be sampling the exterior probes. That's what is causing the leaking. So for those who already tried APV, you know that we could use a volume to add some biases to the sampling location, like the normal biases and the view biases, like this, but that's not a perfect solution, and that's not what I want to use today. So let's skip this flow. So for APV, we recently added some rendering layer support. So you can create up to 4 different masks. For example, one for the exterior and one for the interior. So for the exterior, let's use the default layer because most of the objects are on the default layer. And then you can create another layer, like interior. And then all you need to do is assign the right layer to the object. So it means that it did require to split the mesh between the interior and the exterior. So that was a bit of work on the mesh itself. But then you just have to apply the layers. So let's do this. Basically, for most of the objects of your tent, you don't have to add the layers to everything, just the objects that are subject to leaking. So let's do the wall, the floor, and I'll skip this in the video, but I'll also include the pillows and the carpets, like this. So we just assigned the layers, and then we can bake. And the leaking seems to be completely gone. So let's take a look at the debug view to see what's happening. So let's display the probes and display the rendering layer. So you can see that at baking, some layers were automatically assigned to the probe Basically, it's based on nearby meshes. So during baking, the probes see which layer they hit, and the interior probes, for example, hit a lot the interior layer. So it was assigned automatically. And same for the exterior. So yeah, automatic setup, no need to do this by hand. And then at sampling, we look at the layer that is used by the object, and we exclude the probes that are not on the same layer. So green probes are sampled and red ones are not. So for example, texture mesh should not be sampling the interior probes, and that's the opposite for the interior. So it works even at low resolution. You can see that it sampled the right probes based on the object and the layer. And this layer stuff is only affecting the sampling at runtime. So the lighting stored inside the probe is completely the same. The system is just trying to evaluate the right probes based on the information you gave it. So it's looking great, both from the outside and the inside. And something else to mention for those who know a bit APV is that we added this quality sampling mode. So the performance mode is that what we had before, and basically sometimes it could sample invalid probes. Like here in the ceiling, you can see that some of the red probes are sampled. That's due to hardware filtering. But with the quality sampling mode, you know that you won't sample invalid probe. So it may have a slight performance cost on mobile, but we did not notice any impact on a PS4, for example. So it's almost the same. It's the same on PS4. So currently we are using 1 meter between probes. So can we try with an even lower resolution to see how it looks? Something like 2 meters. And as you can see, we have no leaking at all, thanks to the rendering layers. So usually the resolution was chosen with leaking in mind, but now you can select it based on the quality that you want, and knowing that the leaking can be solved with the rendering layers. So something else that I can say about this is that objects can be on multiple layers. For example,
Hey,
I'm back.
Maxime.
Yeah, I'm back. Yeah, that's my headset.
Welcome back. Thanks.
Yeah. So you can assign multiple layers on the objects. And for example, this object and the entrance can be on the interior ones and exterior ones. So you can have nice transition. So that's it for APV setup. APV has other advantages. For example, you can bake multiple lighting scenario. So it's super useful if you want to do day-night cycles. For example, you can bake the day, the sunset, and the night, and blend at runtime. APV also supports sky occlusion, but I won't speak about this today. It's been already a long presentation, so we'll probably do another presentation or a blog post. So Unity 6 preview is available, so don't hesitate to download it and give us feedback on the forums. Regarding APV, your feedback about leaking was super useful. That's why we added this new rendering layer support. So tell us how you feel about it and if we can still improve it. And yeah, finally, I'd like to thank the whole team for the URP sample, the engineers, the technical artists, to anyone who participated to this project. It was a pleasure to work with you. And yeah, thank you for joining the webinar. Let's see if we have some time for a short Q&A.
Thanks, Maxime. Great to see that. Thanks. If I could invite the other panelists that are available for Q&A to come on camera so we can see your lovely faces. And yeah, so to anyone out there that's with us, if you have any questions for us, just obviously feel free and go ahead. I have a question, Maxime. Those light leaking features you mentioned, Are they available already so people can actually start using them? Have they landed in a beta release, or how is it looking?
Yep, it landed on the latest preview of Unity 6. So yeah,
Great.
you can try those. And yeah, give us feedback on the forums. That's super helpful for IPV. And yeah, I see some questions about some bugs. So yeah, we'll definitely take a look at this and answer on the forums. So forward plus rendering, is it good enough to enable this for mobile platform? Yes, but it's quite expensive. So we did enable it for high-end mobile. If you look at the project settings, so low-end mobile use deferred rendering. So it depends on the mobile. But yeah, if you want many lights, you should use deferred rendering or forward plus. Will some of the features reach the current LTS? Not 22. No, everything for APV is only for Unity 6. But for the first part of the presentation, everything I presented was for the 22 LTS. Yep, no, forward plus rendering is not the way to go if you want to support low-end phones. So a recap of the features that are exclusively in Unity 6. So the only feature I spoke about for Unity 6 is adaptive prop volumes. The rest of it, everything is on the 22 LTS. So adaptive prop volume, Unity 6, that's it. So is your custom fog available for us to see? Yeah, you can look at the URP sample. You can download it from the Unity hub and you can see the fog, you can see all the scripts that we did. Everything that I showed is available except for IPV. But yeah, the script for the fog, the script for the light maps and the LODs. So yep. So nice work. I'm wondering if the real-time lights will have other Fallout settings in the future versions. I don't know. I don't know about this. Could you explain again how you made that skybox? Yep. So I used the PBR sky from HDRP, so I could bake it into a texture. So you can use any software that you want. With Unity and HDRP, at least you have a lot of stuff that you can add. You can add some clouds with the cloud layers, with the volumetric clouds. You can set up the atmosphere, so you can really set up the mood that you want for the sky. And then I baked it, so you can bake it either with a recorder and you can bake a cube map texture, or even if you use a reflection probe, you can get the cube map texture from the reflection probe and use it directly into your URP project as a cube map texture. Will the APV be performant in standalone VR devices? Yes, so APV is done for mobile. Some of the stuff might be a bit more expensive. For example, the blending, if you want to blend between multiple scenarios, but APV is built for URP and for mobile, so you can use it. are the lighting cookie only self-emitting shadows by texture, or they can cast shadows when baking? Cookies should be evaluated when you bake lighting. Is that so, Jesper? Hi.
Yes, they are evaluated, and in the areas of the cookie where lighting is emitted, they will also cast shadows if you enable shadows for the light. You can also choose to not enable shadows for the light for a cheaper version, but yeah, then you don't get the shadows, but you will have the cookie. So it's a way to fake some detail in the lighting for really cheap platforms.
Can we get a detailed process documentation for baking the sky in HDRP to use in URP? Yeah, sure, that's something that we could do. I could either a blog post or in the forums, I could definitely show you how I did for the sky of the Oasis. So do the light cookies have a bigger source than a point, like a disk, sphere, or box? I'm not sure I get it. So basically, light cookies are just a texture that you use on lights. So for a spotlight, you will use a 2D texture, just a regular texture. For a point light, you will use a cube map texture. And then you can bake whatever you want inside the texture to simulate the shadow or a caustic. So just a texture, and yeah.
You can fake it a little bit we have this shadow, the light size for point lights that you can set. That gives you slightly softer shadows. It's a bit of a hack, but it simulates the point light as a small sphere instead of a point. But yeah, but that's orthogonal to the light cookie itself.
Okay. Well, thank you everyone for joining. I guess that's the end.
Thank you.
Thank you. Bye-bye.
Thanks, Maxime, again for showing us this really great webinar.
Yeah. Bye-bye.
Cool. Take care, everyone.
Recording stop. Okay, so this was the webinar. Now maybe, I don't know if you can hear me well. Hold on. Maybe now it's gonna get better. I was also trying to see microphone, because now I'm really thinking about trying to get a mic. Because of the sound quality, I don't think it's that good, or at least not good enough for my live streams, and I really want to improve everything when it comes to YouTube. So yeah guys, well, this was the live stream, I guess. Thank you very much for staying here and being here and all the interaction that we had. I didn't even expect a lot of comments or a lot of activity, but apparently it was. And yeah, maybe now I will go back and study for my exams, because today I spent a lot of time doing something else instead of actually studying. So yeah, I'm the Nonconformist. Thank you again for watching, and I'll see you in the next one. And also, another subscriber just suggested me to create a new Discord server. I'm also considering that in the near future, so keep an eye on my channel, turn on the notifications to be up to date with everything that I'm doing, because I'm a very, very spontaneous person. It's not like I schedule my live stream or something like that. When I know I have something, oh hi Osedmura, you joined exactly at the very end of the live stream, basically. We've been live. Arrived too late, I see. Yeah, I was trying to say goodbye, but you can still watch the live stream. I will keep it here. I promised you that if it would be interesting, I will do a video after it. Well, it turned out the quality was very, very bad. So I don't think I'm gonna do a live stream with it, because I don't want bad quality on my channel. I just want good videos for you. Only upgrade. I'll see you later then. Yeah, but I'm gonna keep the live stream, so feel free to rewatch the live stream. They didn't have this problem before, I think. I don't even know. And I also sign up for a free course tomorrow and the day after. I'm thinking about joining the event. Okay, then better don't waste your time indeed. Yeah, because of the quality, but otherwise I would have done that. Maybe in the future I will sign up for other Unity live streams and we can watch them together. It's very nice and interesting to see your opinion as well, based on your experience, of course, because I'm very new in this field. Bye, see you soon. Next time, try to respond directly by speaking. It would be great. I wanted to do that, but the thing is, I didn't want to speak over them, and I wasn't even able to pause like the video because it was a live stream. But yeah, I mostly want to discuss with you and use my voice, not replying on the comment section. But because I didn't want to interrupt them, I wanted to drop a comment. So yeah, well, this was the live stream again. I see a lot of activity still. I don't know, it feels like you guys don't want me to leave. I mean, I see 4 people watching and we are 4 people here. For me, that's great. It's a lot because I used to do live streams mostly by myself. So now I see all this activity. I'm like, ooh, that's nice. But yeah. Okay, wow, so now we are 5 people. Jesus, you really don't want me guys to leave. Well then, I'm gonna give you hold on, I have to sign up really. This is what I'm planning to do next. I am planning to do live streams with free courses that I got from this guy. I've talked about him a lot of times on my channel. Feel free to check it. Now we will be now. We will be now. What do you mean? As you can see, a lot of things. The live stream just ended for those who the webinar just ended for those who just joined my live stream. And the microphone I was looking at, I hope I'm not okay, so new customer. Wait a second, I wanted to check microphone live what I was looking at, because now I'm gonna literally show you what I'm doing. Oh, Unity 6, it's here, guys. Nice. I'm also very curious about Unity 6. I haven't tried it yet. I don't know, like, all the things that are new out there. Maybe we can actually follow Unity 6 updates or something. Let's see. The next major release. Yeah. What? All this. No, okay, let's watch this one. 1 hour? Damn, I can watch this one. Hello, Amsterdam. Maybe we will watch this together. This is gonna be a start. This is gonna be interesting. Anything important about Unity 6 said during the webinar? Just the lightning techniques, actually. I feel like not a lot about, I guess, AI tools. I mean, not really, but mostly things about the lightning techniques themselves. Hold on, I wanted to see maybe if I can create something. We can watch this one at some point. I think it's gonna be interesting. 2023, 6 months ago, I see. The future of Unity 6. Okay, it was only about URP, mostly, yeah. Unity 6 announced 6 months ago. What's new? Interesting. Multiplayer play mode. I'm very curious how hard it is to build a multiplayer game. I've heard it's a bit hard. And now back to the microphones. I saw one that I really liked, but I was thinking if I need like an arm for the microphone so it's gonna be closer to me while I'm talking, or is it okay if I'm just gonna have one on my table? If you have any recommendations, drop it in the comments, but make sure it's not very expensive because I don't want to spend a lot of money on it. Also, the shipping prices are... yeah, I don't know why I can't find the one I was looking at. That's weird, honestly. Oh, not this one, but kinda like that. I also like the colors. It matches my channel theme. You can see here. That's nice. Yeah. Well, I guess I'm gonna close the live stream for now. Thank you very, very much for watching, guys. And yeah, I'll see you in the next one. Turn on your notifications, please, because I don't know if it's gonna be a live stream tomorrow. I can't promise anything, but I will try my best. Get something you can attach to your t-shirt or something to leave on the table. Yes, exactly, that's what I have in my mind. See you next time. Okay, guys, see you next time. It was a pleasure being live again. Thank you very, 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 very much for all the support. Bye, bro. Bye, bro. And take care. Bye.